Let's take a look at some of the slopes that we will be looking at in this unit. So the first one we want to review is the idea of the positive slope. So here we have a graph reading it left to right. We see that it goes uphill, so we say that the slope is positive, therefore the m value is greater than 0. The next graph is reading it left to right. It looks like it's going downhill. We say that to be a negative slope. Therefore, the m value will be less than 0. One of our special cases that we've been working with in the last unit was the idea of the horizontal line. The horizontal line is said to have no slope, or the m value in this case is actually equal to 0. All right, because it does not rise, the rising has a 0 value, but it still runs for some value of x. My final slope example is going to be that of the vertical line. Remember, the vertical line by definition is not a function, but it is a linear line. So in this case, when I solve it, my m is said to be undefined. And that's because when I look at the x value, it does not have a horizontal run to it. Rather, all it does is rise for some value of y, and I can't divide by 0. Okay, we can't do that. That breaks the mathematical rule of no division by 0. So that's a quick review of the 4 lines we're going to be looking at. Now I can determine the slope of a line by looking at its graph, and if I have it on a coordinate plane and I look at 2 points that have a crossroad, I can determine the slope just by counting how it rises and how it runs. So if I'm starting at one of these points here, I can count up 1, 2, 3, 4 units. So this guy rises 4 units. He runs across in the positive direction 2 units, so he is going to have a rise of 4 but a run of 2. Therefore, the slope is 2. And I can look at that a slightly different way. I can look at that from the other direction. I can actually find the way it runs first. It runs 2 units. It runs 2 units. And it rises 1, 2, 3, 4 from that point. And so we still have the same slope of 2. Looking at my other picture here, we can see that it should be a negative slope. My number should end up being negative. Again, finding 2 points that are at crossroads, I can count down 1, 2, 3. Now this goes down a negative 3 because we're counting down towards the negative numbers. The rise in this case is a negative 3. The run, if I pick up where I left off, it runs across a positive 1. And so negative 3 over 1 is negative 3. And like I said, it should be a negative number. Now we can look at it from another perspective, like we did with our first graph. I can start at this point and I can go up 3, 1, 2, 3 units. So here it's going up a positive 3. So in this case, it rises 3, but it runs backwards towards the negative numbers. So therefore it runs a negative 1. Well, 3 over negative 1 is negative 3. So I still have a slope of negative 3. So that's how we'd find it from a graph. Our final example is to find the slope from a table. Remembering that we have our y values and our x values, we're looking how does it rise, so the y values, versus how does it run. Those are my x values. So let's take a look at the table. Here it's rising a negative 500 because it's actually going down. So we can see there is this constant rate of negative 500. If I look at the way it is running, we can see that it is running as a positive 125 as it changes from one ordered pair to the next. changing that positive 125. So if I fill that in, my rise is a negative 500. My run is a positive 125. We can find that value then to see that my slope is going to be a negative 4. What this says about the graph is that the weight decreases four ounces for each 125 seconds. Take note to the decreases. So this is how I can find slope from a table. You are now asked to go grab the slope by graph and table worksheet and complete that and turn that in to the teacher.